Hi guys, today I'm going to be working with you on adding and subtracting word problems that have fractions in them. So at the very top we can see the acronym RIDER, and we are going to model the problem using read, identify, draw, and evaluate and respond. Alright, now that we have read the directions, we're going to read the problem. And we're, of course, going to start with R. We see it's a word problem, R. Read and annotate the question as needed. So I'm going to have you pause the video, and you're going to read and annotate the question. Pause the video now. Tom planted 5/6 of a row of green beans and 1 4/6 rows of corn in the community garden. How many rows of vegetables did Tom plant? I hope the first thing you thought was, okay, I just read the question, and the question is asking, how many rows of vegetables did Tom plant? Now, what else was important for us to know? You might say 5/6, but we have to know 5/6 of what? 5/6 of a row of green beans. So that sounds important. And he planted it, that's what he's doing. And 1 4/6 rows of corn. All right, we have read and annotated it. Good job. I identify a strategy. So I'm going to draw my quadrants and put I forgot R. R, I, D, E, R. All right, now I'm going to identify a strategy, and I have to decide on the operations and why that operation makes sense. So the operations are addition, subtraction, multiplication, division, and comparing. I'm going to reread the question again so I can figure out, are we adding? Are we putting them together? Are we taking them apart or trying to figure out a missing quantity? Are we making multiple groups of the same number? Are we dividing into equal groups? Are we comparing the amounts? Tom planted 5/6 of a row of green beans and 1 4/6 rows of corns in the community garden. How many rows of vegetables did Tom plant? Now that's our third time to read that. So how many rows did Tom plant? Does it make sense that we would be comparing? Are we comparing green beans and corn? No, we're not. So let's cross that out. Are we dividing into equal groups? No. Are we multiplying? Are we making the same number of groups? It's like 3, 3, 3, 3, 3, 3. No, we're not. So we're left with addition and subtraction. So are we comparing are we trying to find the difference? Difference would be subtraction between green beans and corn? No, we're trying to find out how many vegetables total he planted. So that tells us that it's addition. We want to know how many vegetables, here's the word vegetables, total Tom planted. And this is going to help us when we get to our evaluate section, because we're going to come up with an answer, and we're going to ask ourselves, is that a reasonable number of vegetables that Tom planted? If it's smaller than these, then that's not reasonable because it's way too small and he already planted this many, so it has to be bigger than both of those numbers. All right, on D, draw a model and solve the equation. So we know that we're using addition. I want you to put both of these amounts together and write an equation right here. And then you're also going to draw your model. You could use a bar model, a number line, number bonds. Okay, pause that video and go ahead and do D. Okay, E. E stands for evaluate, is your answer reasonable? So you added 5/6 plus 1 4/6 equals. Is your answer reasonable? Is it larger than both of these numbers? If it is, you're going to say, okay, my answer is reasonable because I was asking how many vegetables total does Tom have? He has to have more than the 2 parts that we put together. So in your own words, right here, you're going to say something about how you know that the number that you got, the number of vegetables, is the total. It's larger than both of the amounts of just green beans and corn. So pause the video and write your evaluation. And then last, we're going to respond. Answer the question and explain your thinking. The question is, how many rows of vegetables did Tom plant? So here we need to restate the question. How many rows of vegetables did Tom plant? Tom planted rows of vegetables. Go ahead and write your response here. Pause the video so you can do that. Good job. I hope that was helpful. Now that took us about 7 minutes to do. This next one is going to go a little bit faster. Okay, I have reposted our RIDER acronym just so we can reference it. I know yours is at the top of your paper. Read and annotate the question as needed. So you're going to, I will read the question to you, but then you need to pause and annotate. Scott drives 2 1/3 miles from school to the grocery store. When he leaves the grocery store, he drives 5/3 miles to get something to eat. Then he drives 1 1/3 miles to get home. How far did Scott drive? So you're going to pause the video and you're going to read and annotate. Go ahead. Okay, so while you were pausing the video, I had drawn RIDER on my paper so that I have enough room to go through all the steps. As I was reading, the first thing I always say is, okay, what's the question asking? How far did Scott drive? Then I, of course, always circle what's important. So the first thing that he did was he drove 2 1/3 miles from school to the grocery store. And the second thing he did was drive 5 5/3 miles to get something to eat. And then he drove 1 1/3 miles to get home. So we have 3 amounts. We need to know how far did Scott drive. We have finished R. Now let's go on to I. Identify a strategy, decide on the operation. Why does that make sense? Write an equation. So let's write out our operations. They are addition, subtraction, multiplication, division, and comparing. All right. Are we putting together all of the numbers? Or are we putting together some of the numbers? Are we saying this amount, and then he drove this amount, and then he drove this amount, will that tell us how far Scott drove? Yeah, it will. So we know that we're going to add. It doesn't make sense to subtract because we have this amount. If we subtracted, he can't drive. Once you're driving somewhere, you can't take away the miles that you're driving. So wouldn't be subtract. We're not making copies of a group. We're not saying this many miles every day of the week. We're not dividing our amounts into equal pieces. And we're not comparing. We're trying to find how much they have all together. So our equation needs to have addition and put them all together. So you have an amount that he started with, that he drove to the grocery store, and then his amount that he went to get something to eat, and then his amount that he went home. Your job is to find how far he drove. So you should have your equation here and your model here, because then we will draw a model and solve the equation. Pause the video and do this, and make sure you also have these three amounts written in. All right, great. Now we're going to evaluate. The amount right here that you got as your answer, we're going to think to ourselves, is your answer reasonable? Does it make sense that my answer that I got is reasonable for how far did Scott drive? If my answer is smaller than 2 1/3 or 5/3 or 1 1/3, then I know that my answer is not reasonable, because when we're adding, our number has to be larger than all of the parts. So if it is smaller than all the parts, then we could say, well, he drove about 2 miles to begin with. Then he drove 5/3 miles. I know that 6/3 is almost 2, so I'll say, yeah. And then he drove about 2 miles. And then 1 1/3, that's about 1 mile. So he drove about 5 miles. If my answer is close to 5 miles, then my answer would be reasonable. I'm going to explain that here. Pause the video to do that. And then lastly, we need to respond by answering the question. This question doesn't tell us to explain our thinking, so right now we're just going to answer the question. How far did Scott drive? Scott drove miles. Go ahead and do that. All right. Pause the video if you're not done and finish this problem. If you are done, let's continue to the back side. Now, I can see that this next problem is a word problem, so I'm already going to write writer. All right. R. Read and annotate the question as needed. Randy took his bird to the vet. The vet recorded Tweety's weight as 1 3/10 pounds. Tweety is the name of the bird, his bird. The vet said that last year Tweety weighed 4/10 pounds more. How much did Tweety weigh last year? So, Randy took his bird to the vet. Is that important? No, it's not. So when we're annotating, we can actually cross that out. The vet recorded Tweety's weight as 1 3/10 pounds. Is there anything important in that part of the problem? Yeah, we need to know that Tweety's weight is 1 3/10 pounds. The vet said that last year Tweety weighed 4/10 pounds more. So we know 4/10 pounds is important. Is anything else important? Yes, that last year Tweety weighed 4/10 pounds more. We must have more. More is a really important word because it tells us about our operation that we're going to choose. How much did Tweety weigh last year? That's our question, so we're going to underline it. All right. I. Identify a strategy. Decide on operations and why that makes sense. So our operations are addition, subtraction, multiplication, division, and comparing. The word more here sometimes tells us that we're comparing. So let's think about that. Tweety's weight is 1 3/10 pounds. But last year, Tweety weighed 4/10 pounds more. How much did Tweety weigh last year? Are we comparing how much more Tweety weighs? No, we're not. So, we are not actually comparing, even though the word more is in question. Are we dividing? Are we putting something into are we trying to split it up into equal groups? No. Are we taking one of these numbers and making equal groups of that number? 4/10, 4/10, 4/10, 4/10? No, we're not doing that either. Are we taking away 4/10? Will that tell us how much Tweety weighed last year? Let's try that. Tweety's weight is 1 3/10 pounds. Okay, I know that I need 1 3/10 pounds. And then if we take away 4/10, will that tell us how much Tweety weighed last year? Well, I have to really read the problem carefully in order to find out if we're going to subtract. So when we're thinking about why that makes sense, we have to carefully reread, not quickly, but carefully. The vet recorded Tweety's weight as 1 3/10 pounds. That's definitely true. The vet said that last year, I'm going to actually highlight that because that seems important. Last year, Tweety weighed 4/10 pounds more. How much did Tweety weigh last year? So we're talking about last year here. The vet said that last year Tweety weighed 4/10 pounds more. So last year Tweety weighed more than he or she weighs this year. So this year is going to be smaller than last year. I'm actually going to write that down. This year, and please write this down with me, Tweety weighs less, and last year Tweety weighed more. So last year should be larger than this year. Pause the video if you need to write that down, or if I'm going too quickly. So this year needs to be smaller, and then our answer needs to be larger because 1 3/10 is this year. I'm still annotating. I like to go back and annotate a lot. So this year is smaller than last year. So when I'm evaluating, I need to make sure that my answer that we got is larger, needs to be larger than this. So will subtracting give us a larger number? No, it will not. So I'm going to take my eraser and erase my subtraction sign here and say, if we're not going to subtract, then that only leaves addition, which will give us a larger amount that Tweety weighed last year. You're going to take this equation and you're going to write it in the D box because we are going to draw a model and solve the equation. Your answer needs to be here. And then you can use a model. Again, if you're using number bonds, that's totally okay. If you're using a number line or a bar model, that's also great. Pause the video if you need more time. All right, E. Evaluate, is your answer reasonable? Is my answer from last year more than what Tweety weighed this year? Yeah. So when I'm explaining, is my answer reasonable? So I could estimate, but these numbers are so close together that estimating might not be the best choice. So I really want to use words to explain about how last year Tweety weighed less, so my answer needs to be more than what she weighed last year. Go ahead, take some time to write that here. Pause the video. And then lastly, my favorite part, R, respond. Answer the question. The question says, how much did Tweety weigh last year? Last year, Tweety weighed, Pause the video, answer the question. Then let's go on to our last word problem. Great job, guys. All right, it's a word problem. So we need to write writer and make our quadrants. Read and annotate the question as needed. Zach spent 2/3 hours reading on Friday and 1/3 hours reading on Saturday. How much more time did he read on Saturday than on Friday? So we're going to annotate, circle, highlight, underline what is important in this question. Pause the video and do that. So of course the first thing I like to do is underline the question. How much more time did he read on Saturday than on Friday? Because that always helps us to identify the strategy. What else is important in this story problem? I'm rereading. Well, 2/3 hours is important, but we must know what else about 2/3 hours. We have to know that he spent 2/3 hours reading on Friday and 1/3 hour reading on Saturday. That's odd. For me, Zach, I spend a lot more time reading on the weekend than during the week. So, how much more time did he read on Saturday than on Friday? Let's think. Decide on an operation and why that makes sense. Addition, subtraction, multiplication, division, comparing. Does it make sense that we are adding them together? Are we putting together 2/3 hours and 1/3 hour? Will that answer our question? We can do that, but will that tell us how much more time he read on Saturday than on Friday? No, that'll tell us how much time he read total. So we are not going to add. are we going to subtract? Are we going to take away? Does that make sense? 2/3 hours, and then we're taking away 1/3 of an hour? Can he reverse time and take back time that he read? No, that doesn't make sense. Multiply. Are we taking 2/3 hours and he's reading 2/3 hours for every day of the week? No, that'd be 2/3 times 7. That's not what we're doing. Is he taking 2/3 hours and dividing it up to do different things? No. Is he comparing the amounts, 2/3 hours and 1/3 hour? Will that tell us how much more time he read on Saturday than on Friday? So I have made a mistake, and that's okay. Everybody makes mistakes. I just have to go back and fix it. Now I have said no to each one of these. One of them has to be correct. So I'm going back and I'm thinking, okay, we haven't done multiplication, division of fractions yet. So those are definite no's. But we have done adding, subtracting, and comparing fractions. Okay, so I'm thinking again, are we putting together 2/3 and 1/3 hour? How much time did he read on Saturday? How much more time? More. Does that mean add? How much more time did he read on Saturday than on Friday? No, if we put them together, that's not going to tell us that he read 3/3 more on Saturday, because he didn't read 3/3 on Saturday. If we're subtracting, if he has 2/3 hours and we take away 1/3 hour, will that tell us how much more time he read on Saturday? Now I realize why I'm so confused. Silly me, I made a mistake. He did not read more on Saturday. I read more on Saturday, but he didn't. He read more on Friday, please make this change with me, than he did on Saturday. Silly Miss Tuxhorn. So if we subtract, we will be able to tell, 2/3 minus 1/3 will tell us how much more he read on Friday. You're going to write an equation, draw a model. I suggest a number bond, unless you really want to commit to a bar model. Then you're going to explain, why does that make sense? Does it make sense that we would subtract because we're trying to figure out the difference? Please use the word difference in your response. Pause the video and write your evaluation of, is your answer reasonable? And last, we are going to respond and answer the question. How much more time did he read on Friday than on Saturday? Zach spent more time reading on Friday than he did on Saturday. Great job, guys. Sorry that I confused you and confused myself on that last one, but that just goes to show that even we as adults who have gone through 4th grade many times have to reread. And we have to really think about what we're doing and what we're thinking about and why it makes sense. Does it make sense? I can add, I can subtract, I can compare, I can multiply and divide, but which one makes sense? They all mean different things. There's 2 more questions at the bottom. If you can solve these independently, just go for it. You don't need to watch this. if you have been struggling a little bit with just straight subtraction problems, I'm going to go through these with you. I'm going to use a bar model, and then I'm also going to show it as a number bond. So our first problem is 3 minus 1 2/5. So I have to draw my 3 holes, because that is the amount that we are starting with. I have 1 hole, 2 holes, 3 holes. And I need to take away 1 hole 2/5. Now I can easily take away 1 hole. There, I just subtracted 1. But I still need to subtract 2/5. Excuse me, I just broke my voice there. So in order to take away 2/5, I do have enough. I have 2 holes. So I need to partition or break down, decompose my 1 hole into fifths. That does not change the amount. I still have 2 holes. But now I have 1 hole 5/5. And now I can take away 2/5. Minus 1/5 minus 2/5. How much is left? Well, I have 1 hole, 1 1/5, 1 2/5, 1 3/5. That answer goes here. I'm going to show you it as a number bond now. So I have 3 holes, and I want to take away 1 2/5. So my 3 holes, I know I have to decompose them so that I can take away fifths, because right now I only have enough to take away 3 minus 1. 3 minus 1 is 2, but I still have my 2/5 left over. So I'm actually going to do this a little differently and say, all right, when I have 3 holes, I want to first take away my fifths. So I'm going to keep 2 of my holes, and I'm going to make my other one fifths, because in 2/5, my denominator is fifths. So in order to take away 2/5, I have to have some fifths. How many fifths is equivalent to 1 hole? 5/5. So we know that 2 5/5 is the same as 3. Here I have 1 hole, 2 holes, there's my 2 holes, and 5/5. Now I can take away 1 2/5. I know that 2 minus 1 is 1. So I had my 2 holes, and I took away 1, and I have 1 hole left. And I know that 5/5 minus 2/5 is 3/5. And I had 5/5, and I took away 2/5, and I have 1/5, 2/5, 3/5 left. So again, I got the same answer. Let's do another one. 4 6/8 minus 3 3/8. Well, I need to use like units. Like units. So my like units here are whole numbers and eighths. If I know that I'm going to do my smaller amounts first, just like when we use a place value chart, we start subtracting in the smallest unit, like the ones place. So we're going to start with the smaller unit, which is our eighths. 6/8 minus 3/8 is 3/8. Then we go to our next larger unit. 4 minus 3 is 1. 1 and 3/8. We're going to check this with a bar model. So you need to first draw 4 and 6/8. Now I know that I have 4 holes, and then I need another hole to have my 6/8. So I'm going to draw my bar model. And I'm going to split it into 5 pieces because I have 1 hole, 2 holes, 3 holes, 4 holes, 5 holes, and I did a really bad job at drawing equal holes there. So sorry. 5 holes, but we're only using 4 of them. So I'm going to shade in 4 of them. 1, 2, 3, 4. And then I need to make 6/8. So because my denominator is 8ths, I need 8 pieces. Partition in half, and then each half in half, and then each of the pieces, each of the fourths in half again. Now I have 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8. And again, I partitioned very badly. I'm sorry. And we're going to shade in 6/8. 1/8, 2/8, 3/8, 4/8, 5/8, 6/8. Now it's time to subtract. And again, we're going to start with our smaller amount, minus 3/8. We're going to take away 1/8, take away 2/8, take away 3/8. And then we're going to take away our holes. We're taking away 3 holes. Minus 1 hole, minus 2 holes, minus 3 holes. What is left? 1 hole and 3/8. So my answer is still 1 and 3/8. Give yourself a star. You're awesome. I hope this video helped you today. And I really hope that you're gaining a lot of confidence in adding and subtracting fractions. I'm very proud of you.